Expired. Oh, now let's go to the gentleman from California, Mr. Knight.
Thank you, Mr. Chair. I'm going to go in a little bit different direction, probably to Mr. Schurr or Dr. McNutt. Are ASRGs, are they already assumed in deep space exploration? Is that NASA is already taking those into effect or into account?
The ASRG project itself, the flight project, was canceled back in 2013. So right now we don't build it into any of our forecasts for future needs as a system that would be available to us. We're still investing in the technology to see if we can develop a technology from that, but we don't build it into any of our forecasts.
Okay, so if we go down the road of going to Mars in the next 16 or 17 years, as the bumper sticker says, if my good friend from Colorado would be here, Ed Perlmutter, he would have his bumper sticker out there. If we assume we're going to make it there in the next 16 years, a lot of these efforts have got to be, or a lot of these problems have got to be fixed. One of them is the propulsion. Obviously, the number one is the radiation to make sure that our astronauts get there and they get back safely. That's always the number one mission. If we are going to get there a little faster, to make sure that the radiation impact is lessened because of less travel time. Is that going to be a part of a new propulsion system, or is that going to be a propulsion system that might be nuclear powered?
I don't believe there's a relationship between the Stirling power conversion and the NTP, the nuclear thermal propulsion. So you see Stirling gets involved when you want to convert the heat that comes off the reactor into electricity.
Right. Okay. But again, if I just follow that question or that line of thinking, we're going to need that kind of propulsion system to get us there quicker. Is that correct?
I actually have to admit that's not my field of expertise. So in the planetary science, our focus is on the power conversion, and I know we have folks in our space technology organization that are working on NTP.
Okay, and now I'm going to go back to what the chairman said about the 35 kilograms. If we have enough to make sure that we're going through 2025 or 2030, and the conversion of this 35 kilograms is proper, or we have enough, wouldn't the ASRGs be a part of that at some point to make sure that we have the burn rate or the conversion rate, or some other technology? It could be something else.
If we're able to develop a dynamic technology that is 4 times more efficient, we'd be able to stretch the supply to conduct 4 times more missions or larger missions. So it is something we are investing in to see if we can make it work. It is technology that would also be applicable to any human-based usage with a fission-based system if one were developed. So the technology has multiple uses, any heat source conversion to electricity. So it is an area that we're going to continue to invest in. Whether it makes sense for planetary missions or not, we have to solve some of the issues that Dr. McNutt was referring to. A dynamic power system with moving parts that can't be maintained for 20 years, you have to make sure there's enough reliability in the system. But those are the things that we're investigating.
Okay, very good. I yield back the balance of my time.